Hi, welcome to In 5 Minutes. We have seen the concept of self-biasing, how to go for the theoretical calculations. Now we'll actually solve a problem on self-bias JFET. Now again, to identify the type, as I have told you, the arrow is always from P to N for the channel, and when it is forward bias, the current will flow from P to N. So whatever you have on the RHS, that is your channel. So in this case it is N channel JFET. Type of biasing is self-biasing, since you don't have voltage connected to the gate. Identify the terminals. You have gate, you have drain, and you have source. So this becomes your drain resistance, this becomes your source resistance. Now the question is to find VGSQ, IDQ, VDS, VS, VG and VD, similar to the problem we have solved for fixed bias. Now for the DC analysis, we remove the capacitance. There is no capacitance in the circuit, and we remove the AC sources. Again, there is no AC source in the circuit diagram. So we start with the DC analysis. This is the circuit for DC analysis. What we are removing from the circuit? When you look here, we are removing the resistance RG, which was there in the circuit. Why we are removing RG is the current IG is 0, as you know, and VRG is 0. So we are removing the resistance RG from the circuit. Right, now start with the mathematical approach. There are two approaches, as you know, mathematical and graphical. First we'll start with the mathematical approach. Now since IG is 0, you know VRG is 0, that is voltage across 1 mega ohm is 0, and since IG is 0, we can say ID equals to IS. Voltage across this resistance is VRS, current is IS, current is ID, and ID and IS are same. So I can write voltage across the resistance RS as ID into RS. And when you apply KVL in this loop, that is KVL to gate source loop, what I will have? Minus VGS minus VRS equals to 0. So I can write VGS as minus ID into RS. So this is another equation I have got. Now from Shockley's equation, we can write ID equals to IDSS 1 minus VGS by VP the whole square. What we have got? VGS. Now this is equation 3. What we'll do? Substitute equation 2 in 3. What will have? ID equals to IDSS 1 plus ID into RS divided by VP the whole square. Now IDSS is given as 8 milliamperes and VP is minus 6 volts. So when you substitute these values, that is 8 into 10 raised to minus 3, 1 plus, since ID is not given, it is ID into 1 into 10 raised to 3. This is ID. So when you solve this quadratic equation, you will get two roots. You will get it as 2.587 milliampere and you will get 13.9 milliampere. Now which to select? From the characteristics, if you know, VDS value should be positive for the operation of the JFET. Whichever region, saturation, cutoff and ohmic region, we need to operate the VDS in the positive side. That is, whatever value of IDQ, we need to find VDS. So how to find VDS? When you apply KVL on this side, it will be 20 minus 3.3 into IDQ. Then voltage is VDS. So minus VDSQ, positive negative, minus IDQ into 1 into 10 raised to 3 equals to 0. So when I am writing this equation again, KVL to drain source loop, what I will have equation? VDS equals to VDD minus IDRD minus IDRS. So when you substitute IDS 2.57, you will get VDS as 8.8759 volts. And when you are substituting ID as 13.9, you will get VDS as minus 38.87. So VDS cannot be negative, so we cannot take ID as 13.9. we will take ID as 2.587. for that we have got VDS as 8.8. so IDQ and VDSQ we have found. Now we can find VGSQ. Minus ID into RS is the value of VGSQ. IDQ is 2.587 and RS is 1, so you will get it as minus 2.587 volts. This is your VGSQ. So we got VGSQ, we got VDSQ, we got IDQ. Now the question tells us to find VS, VD and VG. Now VG, we can see in this gate doesn't have any voltage, so we can say VG is 0. We can say there is no voltage in the gate. Then we can find Vs as Id into Rs, that is voltage. Vrs we can say, and this we get it as 2.587 volts. You know Vgs is Vg minus Vs. Since Vg is 0, your Vs is minus of Vgs. So minus of 2.857 will be plus 2.587 volts. So you got Vs, you got Vg. Now what you are left with is only Vd. You know Vds is Vd minus Vs. You have got the value of Vdsq. You know the value of Vs. So you can find Vd as Vds plus Vs. So you'll get it as 11.462 volts. So this is how we have solved it mathematically. Now we can solve it graphically.